I will take the numericals in current electricity related to the series and parallel combination of resistors, right? So as you know well, series combination of resistors, we used to take some formulae related to series combination of resistors. If the resistors are in series combination, and then here that is Rs, equivalent resistance in series combination, Rs is equal to R1 plus R2 plus R3 plus and so on plus Rn if n resistors are in series combination. For example, for identical resistors, if you take the identical resistors, what is the meaning of identical resistors? The meaning of identical resistors is all the resistors are having the equal resistance. That is R1 is equal to R2 is equal to R3 is equal to and so on equal to Rn, that is equal to R. So all the resistors, first resistor, second resistor, third resistor and so on, nth resistor having same resistance, nothing but capital R. In this case, what is the equivalent resistance in series combination? What is the equivalent resistance in series combination? And that here we are taking it as Rs is equal to, so R1 equal to what? R plus R plus R and so on plus R. It means R plus and so on plus R. Like that, how many times repeated? How many resistors are there? That many times are repeated. So how many resistors are there here? N resistors are there. So n times repeated. So here I am mentioning it as n times. Now Rs is equal to R plus R plus R plus R and so on plus R n times repeated. That here we are taking it as NR. So for identical resistors, if the identical resistors are in series combination, the equivalent resistance in series combination is NR. Okay, and then next come across the parallel combination. So if resistors are in parallel combination, here we are taking the formula for equivalent resistance or effective resistance in parallel combination is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus and so on plus 1 by Rn plus 1 by Rn. Same as the series combination. Here I am taking that concept it as for identical resistors. For identical resistors, here I am taking the concept of. So for identical resistors, here I am taking the part it as, listen, R1 is equal to R2 equal to and so on equal to Rn. That here I am mentioning it as a capital R. Identical resistors 1 by Rp is equal to 1 by R plus 1 by R plus and so on plus 1 by R. Like that, how many times repeated? N times repeated. So 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R plus and so on plus 1 by R. That here we are representing it as N by R. And that implies equivalent resistance in parallel combination Rp is equal to N by R. If you reverse the term, then that is nothing but R by N. This is the formula for that. So in parallel combination, the equivalent resistance, for finding the equivalent resistance, the formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus and so on plus 1 by Rn. So in the same way for identical resistors, simply we are taking the formula it as Rp is equal to R by N. Okay. So now here straight away I am taking the two formulae which we discussed right now in series combination as well as parallel combination. Series and parallel combination. Listen. So in here I am mentioning in series combination, in series combination, Rs is equal to R1 plus R2 plus and so on plus Rn. For identical resistors, if you consider Rs is equal to Nr. These two are the very, very important formula for this. In parallel combination, we are representing here for calculating the equivalent resistance 1 by Rp is equal to 1 by R1 plus 1 by R2 plus and so on plus 1 by Rn. Now here for that, for identical resistors, if you take, then Rp is equal to, what's the formula? R by N. If you take the ratio between the series combination as well as effective resistance in series combination or parallel combination, if you want to take the ratio between the effective resistance of series and parallel combination ratio. So ratio is nothing but here I am taking that Rs by Rp. What is Rs? In case of series combination, identical resistors, Nr. What is the Rp? What is the Rp, ma? And that is R by N. R by N. So R get cancelled and that is nothing but N goes to numerator. N into N, what's the value? N square. So here we are representing that Rs by Rp is equal to N square by 1. Simply here we are taking the part it as Rs is to Rp is equal to N square is to 1. So if they change the order as Rp is to Rs, Rp is to Rs, parallel to series ratio for identical resistors, if they ask, then the value is 1 is to N square. 1 is to N square. Now, what's the formula, ma? Rs is to Rp equal to N square is to 1. So, need to remember these things for solving the problems, right? Now, listen, here I am taking one circuit and draw the circuit also. Draw the circuit by you also, ma. The effective resistance between A and B in the given circuit is, now this is the symbolic representation of the resistor. Okay, so now here I am mentioning like this. And now like this one circuit is present and this is A and this is B. Here the resistances are mentioned as 2 ohm and this is 3 ohm and this is 2 ohm. As you know that ohm is a unit of SI unit of resistance of the resistor, and again same, and this is 2 ohm, 3 ohm, 2 ohm, and here also 2 ohm and this is 2 ohm and this also they mentioned as 2 ohm. Here they need to calculate what is the effective resistance between A and B. We need to calculate RAB is equal to question mark. RAB is equal to question mark. How come solve this? Now come from back. Come from back. Observe carefully. 2 ohm, 2 ohm, 2 ohm. Once the current reached here, now that current is passing in this direction, like this, and like this. There is no deviation in this path. There is no bifurcation in that path. Whatever the current is passing through 2 ohm resistor, the same current passing through this also and through this also. So if the current is same, in the resistors, if the current is same in the resistors, then we used to say that those resistors are in series combination. Why? Because in series combination, the current remains the same. In series combination, which is same, current remains same. Whatever the current is passing through the 2 ohm resistor and this 2 ohm resistor, and this 2 ohm resistor, it means what? All the three resistors are in series combination. If the three resistors are in series combination, straight away remember the formula. Rs is equal to, what's the formula, ma? R1 plus R2 plus R3 plus and so on plus Rn. Here only three resistors, 1, 2, 3. So R1 plus R2 plus R3. 2 in 2 plus 2 plus 2, 6. Now the equivalent circuit, so this is a question, right? So draw this question. Now I'm replacing these three resistors with another resistor, that is called equivalent resistor. That equivalent resistor here I am mentioning like this. Previously, in that place, three resistors are there, all are having 2 ohm. So now, equivalent of all the three resistors, nothing but NR. Identical resistors, no, NR. 3 into 2, 6. So this is 6 ohm. Now, come to here. At this point, current is moving in this direction, So current is dividing here. Current is dividing. When the current is dividing in two different paths, then in the two different paths, whatever the resistors are present, those two resistors are in parallel combination. Where the current is bifurcating, where the current is moving in two different paths, in the two different paths, in this path one resistor is there, in this path one resistor is there. So these two resistors are in parallel combination. Once the two resistors are in parallel combination, what is the effective resistance? 1 by Rp is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2. Why? Because only two resistors are there. Now the same formula can be rearranged by taking the LCM. If the circuit consisting of two resistors and those two resistors are in parallel combination, this is the effective formula. Rp is equal to R1 R2 by R1 plus R2. R1 plus R2. So now 6 into 3 by R1 is 6, R2 is 3. 6 into 3 by 6 plus 3. 6 3s are 18. 18. 6 plus 3, 9. That is equal to, what's the value? 2 ohm. 2 ohm. So in the place of 3 and 6, this 3 and 6 can replace with 3 and 6 replace with only one resistor having the value is 2 ohm. 2 ohm. Now 2 ohm, 2 ohm, 2 ohm. All the three are again series. So again you will get 2 plus 2 plus 2. Otherwise 3 into 2, NR formula. So now here that value became as 6. 6 ohm. Now again this 6 and 3 parallel combination. Why? Because from here the current is moving in two different paths. So 6 into 3 by 6 plus 3, 18 by 9, that is equal to 2 ohm again, 2 ohm again. So this 3 ohm and 6 ohm again replace with 2 ohm. Now in between A and B, there is no another circuit. Whatever the current is passing, that current is traveling only in one direction. There is no deviation in the path. So all the three resistors are in series combination, 2 plus 2 plus 2. Otherwise, NR formula, three resistors are there, 3 into 2, 6 ohm. The answer is RAB is equal to the equivalent resistance across A and B is 6 ohm. Got it? అర్థమవుతుందమ్మా? Now I'm taking another problem. See, now they're taking the circuit here. This is the circuit. So in this circuit, here we are mentioning this is 5 ohm, 5 ohm, and this is 20 ohm, and here 5 ohm, 10 ohm, 5 ohm. This is 5 ohm, and this is 5 ohm, like this. Okay. Now here they mentioned here this is A and this is B. The question is, find the equivalent resistance between A and B. RAB is equal to question mark. RAB is equal to question mark. Now how can we solve this? How can we solve this? See, the current is passing in this direction. Remember one thing, like these circuits, A and B, AB, otherwise PQ, otherwise XY. Like these notations are present. Like these notations are present there. Here we are considering like first letter is positive terminal. First letter represents the positive terminal. The second letter represents the negative terminal. Second letter represents the negative terminal. Okay. Now see here. A is first term, first letter. B is second letter. So A is connected to positive and B is connected to negative. Like that, we need to consider. Remember carefully. Now, from the positive, anyway, the current is passing in this direction. So the current is moving in this direction up to here. But to move from here, there is no closed circuit. Here it is opened. Here it is opened. Actually, this is the problem. This is the problem. A is connected to positive and B is connected to negative. For your attention, I am taking that this is positive and this is negative, like this. To your attention. Okay. So now here there is no any further circuit, connecting circuit. It means this part of the circuit is opened. In open circuit, no current flows. In open circuit, no current flows. So these two are invalid. These two are invalid. Now, here I am taking that. So invalid means what? Even though those are present in the circuit, with that, no use. With those two resistors, no use. So here I am removing those two resistors from the circuit. Are you getting me? I am removing those two resistors from the circuit. So I removed. Already I said the reason. Why? Because those two are under the open circuit. So in the open circuit, no current flows. So I removed those two. Listen carefully. Now the remaining part. The current is passing through 5 ohm. The same current is passing through another 5 ohm. The same current is passing through the 10 ohm. The current is moving in this direction. There is no another deviation. So these three resistors are in series combination. These three resistors are in series combination. Once we are considering as these three are in series combination, apply the formula Rs is equal to R1 plus R2 plus R3. So immediately we need to remember all those formulae. Okay. So now Rs is equal to what's the one? R1 plus R2 plus R3. So R1 is nothing but 5 ohm. Rs is equal to R1 plus R2 plus R3. Then Rs is equal to R1 is 5, R2 is 5 and R3 is 10. 5 plus 5 plus 10. Then Rs is equal to 20 ohm. So instead of these three resistors, I am placing only one resistor that is equivalent to 20 ohm. Equivalent to 20 ohm. So here I am replacing all the three resistors with one resistor which is equivalent to 20 ohm. Okay, now how these two resistors are in series or parallel? or in series or parallel, ma? Parallel. These two are in parallel. So once these two are in parallel, then immediately need to remember the formula, that is, in case of parallel combination for identical resistors, this is 20 and this also 20. What's the formula, ma? R by N. R is nothing but 20. How many resistors are there? Two resistors are there. So 20 by 2, that is equal to 10 ohm. Now replace all these two resistors with only one resistor. One resistor which is equivalent to 10 ohm. Now RAB equal to these three are in series combination. So 5 plus 10, 15 plus 5, what's the value? 20. Why? Because in series combination the formula is R1 plus R2 plus R3. So this is the option. Then another question, Redoma. Another question, ma. Now this is the question, another question. Four identical resistors are represented as shown in the diagram. Okay, so each resistance is having value 2 ohm, 2 ohm, 2 ohm and 2 ohm. Now the question is, the equivalent resistance between the points A and B is R1. The equivalent resistance between the points A and B is R1. So it means RAB in the problem mentioned as R1. The resistance between A and B is R1. And that between A and C, RAC, is nothing but R2. RAC is equal to R2. Then the ratio of R1 by R2 is, then the ratio of R1 and R2, otherwise R1 by R2 is. Remember, once again I'm repeating the question here. At first try to understand the question, ma. At first try to understand the question. In this question, four identical resistors are present, and these four identical resistors are represented as shown in the diagram A, B, C, D. In the problem mentioned that the resistance between A and B is R1. The resistance between A and C is R2. Then what is R1 by R2? That is the question. Then what is R1 by R2? That is the question. Very simple. Try to understand that. Try to understand that. Listen. At first, I'm taking the R1. At first, I'm taking the R1. So for R1, here I'm taking. Listen, ma. If you are taking the two ends, if you are taking the, remember carefully, whatever the ends you are considering, with respect to those two ends, the remaining part is parallel. For example, if you are taking A and B, except this, the remaining is parallel to A and B. Then at that moment, what is the circuit? What is the circuit? See here. This is this end, A and B. This is A. Okay, 2 ohm. 2 ohm. Alone I am writing this. The remaining part is parallel to this. Parallel to this 2 ohm. It means, how come we consider that? So from here, if you represent like this, if the current is passing like this, current is bifurcating in two paths. It means 2 ohm current, 2 ohm resistance, one current is passing. and the remaining current is passing like this. So it means, see here, current is coming, moving, 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 and reached this point. From here, this current is coming, and from here, this current is coming. For example, this is I1 and this is I2. I1 is coming in this direction, and I2 moving in this path, and moving in this path also as I2, moving in this path also I2. So previously I said to you that if the current is same, then those resistors are in series combination. So I2, I2, I2. There is no deviation in this path. So all these three are in series combination. Series combination. So I am mentioning like this: 2 ohm, 2 ohm, 2 ohm. Got it? So whatever the ends you are considering with respect to that end, those two ends, the remaining resistors are in parallel to that. Here across AB, only one resistor is present. We are considering at first AB. R1 means what? RAB. So with respect to this 2 ohm resistor, the remaining all are in parallel to that. So these three resistors are in series. Why? Because there is no deviation in that. And that's why here we are taking that RAB, or if here it's very clear that this one, and this one, how these three are series combination. In series combination, what is the equivalent resistance? 2 plus 2 plus 2, 6 ohm. So here I am taking that this is 2 ohm and this is 6 ohm. This is A and this is B. RAB equal to, now that RAB equal to that itself is R1 is equal to, how these 2 and 6, these two are parallel, and that's why here we are taking that R1 R2 by R1 plus R2, 2 into 6 by 2 plus 6, 8, 2 that is 2 ones are 2 fours are 2 3 2 2, that is equal to 3 by 2. This is R1. This is R1. So we calculate R1. Now come to the R2. For R2. Now, so for R2, how come we consider that? I'm replacing all this diagram once again. Listen. So R2 is in between A and C. R2 is in between A and C, right? A is here, C is here. Okay, now listen, ma. So I'm reconstructing the diagram, like here. So this is A, B, C, D. I'm reconstructing. In between A and C, I want. So here I'm taking that A is the positive terminal, and C is the negative terminal. So I'm considering like this. A is positive, and whereas C is negative. Like that I considered. Previously A and B. So A is positive, and B is negative. Now what is that? A is positive terminal and B is negative terminal. With respect to this, listen carefully, ma. Very, 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 very important. If you are taking A and C, just I am taking one dotted line like this. The dotted line itself is here. It means instead of giving the connection like this, you connect the battery here also like this. So at that moment, no need to consider like this. For your understanding purpose, I consider the circuit in that way. See, listen here carefully. Once A is positive, A terminal is connected to positive and C terminal is connected to negative. Now the current is coming in this direction, moving here, and listen, current at this point dividing into two paths. In this way some current is passing, in this way some current is passing. This is I1, here I am taking I2. So in this is the value is 2 ohm and this value is 2 ohm. I1 current is passing this 2 ohm resistance. The same I1 current is passing in that resistor also. So these two are in series combination. So replace these two resistors with one resistor. Series combination means what? 2 plus 2, 2 plus 2, 4 ohm. So here instead of these two, I am taking that 4 ohm. Now here another 2 ohm resistor, I2 current is passing. Here also another 2 ohm resistor. So the current is passing like this. I2 is passing like this. Same current is passing. I2 current is passing these two resistors. So 2 plus 2 again. Series combination? No. Same current means series. Remember that. Different currents means parallel. Okay. Now here 2 plus 2 is nothing but again what's the value? 4. Now, with respect to this, current is now here, the current is, some current is, that is I2 current is moving in this direction, I1 current is moving in this direction. Two different currents. That's why these two resistors are in parallel. So once these two are in parallel, then that is R2. They mention it as R2. RAC is nothing but what? R2. The resistance between A and C. That is identical resistors, no? And that is 4 by 2. That is equal to what's the value? 2 ohm. Now, what is the question? This is not our question, right? What's our aim here? R1 by R2 we need to calculate. R1 by R2. What is the R1? 3 by 2. What is R2? By 2. By 2. And that is nothing but what? 3 by 2 means 3 by 4. The answer is 3 is to 4. R1 is to R2 is equal to what's the answer, ma? 3 is to 4. Okay, got it? This is one circuit diagram, another problem. Okay, so in this circuit diagram, they mentioned here AB. This is A and this is B. Question is, what is the equivalent resistance between A and B? What is the equivalent resistance between A and B? The equivalent resistance between A and B here we are taking at first. Remember, where is A? Here it is A. It is positive and this is negative. The current is moving from positive terminal like this. So the current is passing like this. Observe carefully and moving like this. So the same current is passing like this also. So 3 plus 3, these two are series. 3 plus 3, 6. Replace these two resistors, 3 ohm and 3 ohm. Why? Because this current, for example, this is I, and same current is passing like this also, I. If the current is same, current is moving like this, right? There is no deviation, only one path. So if the current is only moving in one path, then those two resistors are in series. So 3 plus 3, R1 plus R2, 6 ohm. So replace these two resistors with 6 ohm. Now, this is A again, same point. Current is moving like this. At this point, current is dividing into two paths. This is I1, for example, this is I2. And I1 and I2, both are different currents. So parallel combination. So 6 and 6 parallel. So if series combination, RS is nothing but 3 plus 3, 6 ohm. Parallel combination is nothing but RP is equal to 6 into 6. Otherwise R by N. R by N, identical resistors. 6 by 2. That is equal to how much? 3 ohm. So replace these two resistors with 3 ohm. 3 ohm. Now again 3, 3 series combination. 3 plus 3 is nothing but what? 6. So replace these two resistors with 6 ohm. Observe carefully. And again 6 and 6, these two are parallel. If 6 and 6 are parallel, then what's the value? 3. 6 and 6 parallel, you will get 3 and replace that with 3. And again, see, current is moving in this direction, in this direction, in this direction. Same current is passing. 3 and 3 are series. If 3 and 3 are series, you will get 6. 3, 3 mentioned as 6. And this 6 ohm and this 6 ohm, these two 6 ohms are in parallel. 6, 6, you will get as 3. Listen carefully now. Where we need to calculate the equivalent resistance across A and B. Across A and B. So, with respect to this A and B, this entire part is in parallel. Why? Because from here, current dividing into two paths. For example, this is I1 and this is I2. I2 same current is passing through this 3 ohm also. So these two 3 ohms are in parallel series, right? So that's why instead of 3 ohm and 3 ohm, two resistors, here I am mentioning only with one resistor, 3 plus 3, that is equal to what's the value, ma? 6. Finally, we need to calculate RAB. RAB, that is equal to this 6 ohm and 3 ohm. These two are in parallel. Why? Because currents are dividing here, I1 and I2. Thereby, 6 into 3 by 6 plus 3, R1, R2 by R1 plus R2. 18 by 9, and the answer is 2 ohm. Answer is 2 ohm. Got it?